question says, a standard solution was prepared by dissolving 2.6061 grams of sodium carbonate in distilled water and making up to 250 cubic centimeters of solution. A 25 cubic centimeter portion of the solution was titrated against hydrochloric acid, and 18.7 cubic centimeters of the acid were required for neutralization. What is the concentration of the acid, given that the relative molecular mass of sodium carbonate is 106? These are the diagrams that try to simplify what is happening. This is the 250 cubic centimeters of solution that was prepared by dissolving 2.6061 grams of sodium carbonate. These are grams of sodium carbonate in this solution. Then the volume was made to 250 cubic centimeters. Then we are told that 25 cubic centimeters was then transferred into a conical flask, and then from there the solution was titrated using hydrochloric acid. Okay, I want you to note that solution 2 and solution 1 are one and the same thing, except that they differ in volume, therefore their concentrations will be the same. Since solution 2 is obtained from solution 1 and was never diluted nor any solute added to it, therefore the two solutions have got the same concentration. Bear that in mind. Okay, we are told that this sodium carbonate solution is titrated using hydrochloric acid. That is the hydrochloric acid that is used. And the question says 18.7 cubic centimeters of hydrochloric acid were used to neutralize the sodium carbonate. We are now asked to find the concentration of the solution. What is the concentration here? That is our task. That is what we should find. Now, let us take a very quick recap. When you are working with moles, it is important to remember these three formulae. The first one says moles is equals to the mass in grams of a substance divided by the relative molecular mass of that substance. The number of moles of a substance equals to the concentration of the solution multiplied by the volume of the solution in which this substance is dissolved. Then finally, the moles of a gas is equals to the volume of gas divided by the molar volume of gas at room temperature and pressure, which is 24 decimeter cubes. Now, this question wants us to find the concentration of the hydrochloric acid. From these three formulae here, we find that the formula that is appropriate to use is this one that says concentration equals to moles divided by the volume. We want to find the concentration. This is why we are going this formula. All right? Now, we also find that we are given the volume of hydrochloric acid as 18.7 cubic centimeters, which converts to 0.087 decimeter cubes. Give yourself a break and calculate this value. See if you will arrive here. Convert the cubic centimeters to decimeter cubes using the conversion. 1 decimeter cubes is equivalent to 1,000 cubic centimeters. See if you will arrive at the same value that I have got. It's very important for your practice. But we also note that we do not have this number of moles. We are not given the number of moles. So we will not directly substitute into this equation and then get the concentration. Our task is to find the number of moles of hydrochloric acid. How do we find these moles of hydrochloric acid? To find the number of moles of hydrochloric acid, we need to find the number of moles of sodium carbonate that is reacting with the acid, and then use the stoichiometric ratio. That is, we need to know the moles of sodium carbonate Na2CO3 in the 25 cubic centimeters of solution that was used. Then we can easily apply the stoichiometric formula that says HCl sodium carbonate according to the reaction equation. Hydrochloric acid will react with sodium carbonate Na2CO3. This is an acid carbonate reaction, and acid carbonate reaction produces a salt. Therefore, we'll get sodium chloride as our salt. Along with the sodium chloride, we will get water and the gas carbon dioxide. Carbon reactions of carbonates produces the gas carbon dioxide. Okay, let's quickly balance our reaction equation. You will note that we've got one sodium atom here and we've got two sodium atoms here, so a 2 here, so that we've got two sodium atoms, one carbon, 3 oxygens, one chloride, 2 chlorides, a 2 here. There with my pen. Okay, let me cancel that. All right, a 2 here. So we've got 2 hydrogens here, 2 hydrogens in H2O, 2 chlorides, and 2 chlorides. So according to this reaction equation, the stoichiometric ratio is 2 moles of hydrochloric acid to 1 mole of sodium carbonate. So we need to find the number of moles of sodium carbonate so that we can now use that together with the stoichiometric ratio to find the number of moles of hydrochloric acid. How do we find the number of moles of sodium carbonate in the 25 cubic centimeters of solution? We can easily apply the formula moles is equals to the concentration times the volume of the solution. We know the volume of the solution is 25 cubic centimeters, which converts to 0.025 decimeter cubes. So once again, give yourself a chance to convert from cubic centimeters to decimeter cubes just for practice. So the volume is 0.025 multiplied by the concentration. We do not have the concentration of the 25 cubic centimeter solution. That's not been given to us, so we need to find it. How do we find the concentration of this 25 cubic centimeter solution? The 25 cubic centimeters solution of sodium carbonate was obtained from the 250 cubic centimeter stock solution, and it was not diluted. No solute was added, so the two solutions have got the same concentration. This is what we said earlier on. These two solutions have got the same concentration. They are one and the same thing. The only difference between them is the volume. All right. Now we can apply the formula, or we can find the concentration of the 250 cubic centimeter solution. Once we know it, then we will know that it is the same as the concentration of the 25 cubic centimeter solution. And how do we find that concentration? Concentration equals to moles divided by the volume. The volume is 250 cubic centimeters, which is 0.25 decimeter cubes. Once again, give yourself a chance to practice. The number of moles of sodium carbonate in the 250 cubic centimeter solution is not given, so we will not directly substitute here. We first of all have to find the number of moles in the 250 cubic centimeter solution. How do we find those moles? The question says A standard solution was prepared by dissolving 2.6061 grams of sodium carbonate, and the solution was made up to 250 cubic centimeters. So we have the mass of sodium carbonate here that was dissolved. So we need to change this mass to moles. Applying the formula, mass is equals to, or moles is equals to mass in grams over the relative molecular mass. The mass is 2.6061 grams divided by the relative molecular mass given as 106, and when we press the calculator we get this answer as 2.6061 divided by 106, the relative molecular mass, and the answer that we get is 0.024585. I will round off to 3 significant figures and my answer will be 0.0246. 0.0246. These are the number of moles of sodium carbonate that were dissolved to make the 250 cubic centimeter of solution. These are the number of moles that we want in order to calculate the concentration of the solution. Let's just confirm this answer, 0.0246. That is the same as 0.0246 that we have. Now we can substitute and say the concentration of the solution is equals to the number of moles, 0.0246 divided by the volume of the solution, which is 0.25 divided by 0.25. Note that these are moles and this is decimeter cubes. Therefore, the concentration, we will obtain it as our number of moles divided by the volume, 0.0983 to 3 significant figures, 0.0983, and the units are moles per, that will be per decimeter cube. Decimeter cube. This is the concentration of the 250 cubic centimeter solution, which we said is the same as the concentration of the 25 cubic centimeter solution. Therefore, the concentration of the 25 cubic centimeter solution is 0.0983. The concentration here is 0.0983. Therefore, applying this formula, we have moles is equals to the concentration, and our concentration is 0.0983 multiplied by the volume of the solution, which is 0.025, 0.025, and that will give us, that is our concentration there, multiplied by 0.025, and the answer that we get is 0.002458. Round off to 3 significant figures and you get 0.00246. 0.00246. These are the number of moles of sodium carbonate in the 25 cubic centimeter solution. Therefore, these are the moles that reacted with the hydrochloric acid. So the number of moles that reacted with the hydrochloric acid is 0.00, just confirm that value, 246, 0.0024 and 6. By cross multiplication, if you've got a problem with your the arithmetic here, please see your math teacher so they teach you how to do cross multiplication. the value of x is equals to x times 1 is x, 2 times this number of moles multiplied by 2, and our answer is 0.004917. To 3 significant figures, that will be 0.00492. 0.00492 moles of hydrochloric acid. We now have the number of moles of hydrochloric acid, and we can find our concentration. The concentration is equals to moles divided by the volume. The volume is 0.0187. This is the volume from the burette. And the number of moles we have calculated as 0.00492. These are moles. Substitute into equation. We've got the number of moles here, 0.00492. We've got the volume here, 0.0187 decimeter cubes, and that will give you an answer of 0.263 moles per decimeter cubes. This is the answer that we are looking for, the concentration of the acid. This is a beautiful, beautiful question that is able to push all your nerves. Don't fear questions like this. If you can solve these questions, I'm telling you, in the examination where you are given guidelines of what to calculate and which figure to use there, to use where, you will not have any problems. Thank you very much for joining us. See you at our next lesson.